Let us go deep into the theory behind this LCR circuit. LCR is a combination of LCR. In this LCR circuit, we have to understand, is there any phase difference between the current and voltage of the LCR? If there is a difference, by what angle it is differ, that we require to understand that. To understand that, let me recall the previous classes. If the AC circuit has only pure resistor, you know that in that circuit, as usually we have two signals, the voltage signals and current signals. They are in the sinusoidal form, like this. And look at these sinusoidal waves are in the same phase. Same phase means the peak values, all the peak values are coincided, all the zero values are coincided, showing that there is no phase difference between these signals, the sinusoidal waves, that is the voltage wave and current wave. If the AC circle consists of a pure inductor, and that circuit produces similar kind of sinusoidal waves, but we will find a difference in angle between the voltage and current. That case, voltage leads the current, or current lags the voltage by pi by 2. That case, if the AC circuit consists of pure C capacitor, that circuit also produces similar kind of sinusoidal waves, but in those waves you are finding a difference again. There is a difference in phase angle between the voltage and current. Voltage lags the current, or current leads the voltage by the angle of pi by 2. That we find the differences between the pure components in AC. These voltages, can be represented in a single diagram. With a difference in phase angle between them on the plane of two coordinates. That is known as phasor diagram. What is a phasor diagram? It is a representation of the voltages of the single components in AC with a difference in phase angle on the plane of two coordinates x and y. It is known as phasor diagram. This is a plane of xy coordinates. If you write the direction like in the anti-clockwise direction, it indicates the increase in angle. If you write the same in the reverse direction, it indicates the decrease in angle, this direction. If you move from this point to this point in the order of increasing angle, this point leads this point, or this point lags this point. If you move in the reverse direction like this, from this point to this point lags this point. or this point leads this point. So with this knowledge, let us write the phasor diagram for these voltages. Let me write, let me draw a reference line like this in this direction, making an angle theta with x angle, with x axis. This theta is equal to omega t, that is a sinusoidal angle, this dotted line. This dotted line represents the current. The current, let us say that current angle remains same. This current remains same in all the components, the individual components as well as the combined circuit. This is the line reference line. With reference to this line, let us write the lines of voltages. The solid line and the same line. The solid line represents the voltage in the circuit like this. It indicates there is no phase difference, there is no angle difference between these two lines are in the same phase. This is for this circuit. And I said the inductor, if we talk about the inductor leads the current by 90 degree or pi by 2. Then we have to draw a line, that is a straight line perpendicular to this, that is 90 degree. Then this line will represent the voltage line for the inductor. Similarly for the capacitor, in capacitor, the voltage lags behind, the voltage lags the current by 90 degree. Then we need to draw a straight line perpendicular to this, in this direction, 90 degree. This line represents the voltage in the capacitor. Now, voltage in the capacitor. Look at that. This phasor diagram consists of all the voltages. All the voltages representing a difference in phase angle. It is called as phasor diagram. Now, if you look at this diagram and understand that there are three vectors. These are lines representing the vectors. These are the vectors of voltage, because voltage is a vector. It has both magnitude and direction. Direction in the form of angle. Magnitude. What is magnitude? Magnitude I am taking as a peak value. So length of the line represents the magnitude, the peak value of the voltage. This is peak value of this voltage. This is peak value of this voltage. These are three vectors. So this vector, you will see that in this geometrical arrangement, it is called as phasor diagram. And this mathematics, I mean the mathematical concept, that is algebraic vector and the geometrical concept is the mathematical approach. It is a mathematical approach to find a solution for this LCR circuit. And this mathematical approach, as I said, it is a vector algebra combined with geometrical concept. And the mathematical approach, what you have followed in the previous class, it is a different way. It is in the form of differentiation and integration. Now it is in algebraic vector algebra. Once if you put this phasor diagram is useful, leads to solution for finding any difference in phase angle between current and voltage. And also in doing so, and what is the phase angle, difference in phase angle? By doing so, we will understand or we are able to derive an important expression. One important expression, that is impedance of LCR. Impedance of LCR. What is meant by impedance of LCR? That is Z. You can derive that expression, that particular expression per set. Impedance is the resistance offered by the LCR circuit. Is the effective resistance offered by the LCR circuit. Is a total effective resistance offered by this LCR circuit. Each individual component offers its own resistance to the flow of current. This will resist the flow of current by converting current into heat energy. There you find loss of energy. This will oppose the flow of current by a different concept. By storing energy in the electric field and releasing the same. This also opposes the flow of current. The concept is different. By storing energy in the magnetic field and releasing the same. It is in every half a cycle, I am recalling that. So this direction indicates that the electric energy store up, energy release. Energy store up, energy release. Energy store up, energy release. So every half a circle, there is a store up and release and getting compensated. No net gain or loss in energy by these components while opposing the current. But there is a loss in current while opposing the electric current. Look at the difference. That is the concept. The total effective resistance of all the components, it is the resistance of this LCR. It is given, the term is known as impedance of LCR. Let us go for the derivation of this. Now, the same diagram I have written here, there is no difference in this case. The same diagram I have put here. In this diagram, look at the same diagram here. In this diagram, just concentrate on these vectors, voltage vectors. There are three vectors and directed in three different directions. The resultant of these vectors, here the vector means the resultant of all these vectors is the resultant vector of this LCR. This is the voltage of LCR we are finding. After finding the resultant of these vectors, we get a line like this. This is the resultant vector showing the direction of the resultant voltage and the magnitude of the voltage, peak value of the voltage. And when you see that there is always a phase difference between the current and the voltage. The phase difference is pi, and this voltage lags behind the current, or current leads to voltage in the LCR circuits. That we understood by this phasor diagram. Now we need to evaluate what is V. How do you find the resultant of these three vectors? So this is what I have written. I said this one, that is this line represent, that is due to R. This line is due to L. This line is due to C. And see what is there in the phase angle difference. To find the resultant of these three vectors, it is not possible to find out the resultant of all these three vectors simultaneously. Let us find out the resultant of these two vectors first, because they are in the same line in the opposite direction. In the opposite direction. The resultant of these two is subtraction. And subtraction and direction is direction of the larger value. Let us say consider this. If this value is larger than this, consider not this one, sometimes it is larger, sometimes it is larger. Consider this is larger than this. If so, the resultant is VC minus VL. We get this. And the direction is this. Direction is this. This OA is the resultant of these two vectors. And finally we have these two vectors. Then we can find out the resultant of these two vectors with the angle difference here. The resultant of these two vectors is found by using the law of parallelogram or rectangle. In this diagram, using rectangle, we can find out the resultant, because these two vectors are differ by pi by 2. So when you draw a parallel line from this point, draw a parallel line and then meet here, we get a rectangle. When you draw a line that is from this point to this point, this becomes the diagonal of the rectangle. The diagonal of the rectangle. This diagonal of the rectangle is the resultant of this two vectors. This V is called as voltage in the LCR. Voltage in the LCR. Find this difference. And overall, what is V? This is how we can find out the resultant of all these vectors. This is how we find the voltage in the LCR. You have to evaluate mathematically V using this diagram. So in this diagram, we have a geometrical shape like this. That is a rectangle triangle. That is rectangle triangle is there. Using this rectangle triangle, the Pythagoras theorem, let us apply Pythagoras theorem. This I call this square is equal to square of this length is equal to sum of the squares of these two lengths. This length is same as this length. So this length is VC minus VL. This length is VR. This length is V. Apply Pythagoras theorem. Pythagoras theorem is, that is V square is equal to this square plus VC minus VL whole square. That is sum of this square of this. The equation in the form of voltage, the peak values, the peak value of the individual components, the peak value of the LCR circuit. Let us write these voltages in terms of current and resistance. And resistance of the corresponding components like this. V is equal to IR. What is V is equal to IR? Ohm's law. So these voltages, alright, how these voltages VR, VL, VC and V. In terms of the current, the same current is there in all the circuits, and their resistances are R here, and the resistance is XL, and the resistance is XC, and the resistance is Z. This resistance is called as inductive reactance, This resistance is called as capacitive reactance. I told you in the previous class that is a resistance offered in terms of it is called as inductive reactant is called as capacitive reactance. So these are related to angular frequency and LNC. So all these voltage values in terms of current and their corresponding resistance. This resistance is the resistance offered by the LCR circuit, set impedance I said. Substitute all of them into this equation and see what we get. This equation we get same thing as O square. On the right hand side, I square is common. Take out I square common factor from this, and this I square and I square get cancelled. Remaining is this we get, and Z square is this. What is Z? Z is equal to square root of R square minus XC minus XL whole square. This is the expression for impedance of LCR. What is the expression? Mathematical equation for impedance of LCR. This mathematical equation is a function of this equation. That is a function of our XC and XL in this function. If you know the values of our XC and XL, you can find out the impedance of the R LCR. This finds this is how we can derive impedance of LCR using phasor diagram. And we understood that there is a phase angle difference between the current and voltage by pi. Next, you have to find out what is the magnitude of pi. What is that phase angle? How do you find out this phase angle? Using the same geometry. What is the geometry here? Right angle triangle we have. Right angle triangle here. In this right angle triangle, apply the tan of this. The function of tan on this angle. This tan phi. This tan phi is equal to. This tan phi is equal to opposite by adjacent. What is opposite? VC minus VL. VC minus VL. It is VR. Tan phi is equal to VC minus VL divided by VR. And substitute for these voltages in terms of current and the corresponding resistances, similar to the previous one. And I is common, take out common factor, and I is here, get cancelled. Remaining is this. Look at this. What is theta finally? So theta is the inverse of this function. So eta is the tan inverse of XC minus XL divided by R. So eta is a function of these values. If you know these values, you can find out the value of pi. This is how the pi value is found using the phase diagram, and also the phase difference between the voltage and current. And in doing so, you also get an important expression, that is the expression for impedance. This is what the impedance. This mathematical expression is very, very important, because I told you in this, what is that? Just to convert the signal into, that is some specific, the signal of specific frequency, and the filter, that is selection of one particular frequency among the mixture of frequencies, that is a filter. And these applications, so you are finding the applications, the function, what is the main function? The main function is the selection of the frequency from the multiple frequencies. That is one point. and converting the electrical signal into one specific signal of high amplitude. That is both done by this LCR circuit, and which can be explained clearly using this. When that will act as a filter or amplifier, that is the one the equation explains this. That will explain in the later class. That is the significance of impedance of LCR. This, let us find out this problem.